Hello. If you're watching this, you missed day one of our week 17 Foundations of Technology class. Let's get to it. So this is a wrap-up class right before break, taking it easy, doing some last-minute house cleaning, making sure your catapult project is finished up, meaning I have all 4 checkpoints. Please double check I have those going into break, so you don't have to do anything over break. We did a short warm-up, which is your last grade before break. I'll go over that in this video. And then we played some Scribble.io orthographic projection games. My objectives are that you can reflect on the construction process for your catapult project, and you can draw isometric diagrams and orthographic projections. For the warm-up, we have a graded one. Let's take a look at it together. It is posted on MyMCPS and looks like this. So you need to make sure you do this. You should probably read through this carefully, understand what's going on, and then answer the following questions. Now, I'm going to go ahead and help you out with this one right here. Arrange the following quantities into an equation below that makes sense. Input lift, input arm length, and output arm length. So it's important to understand what these things are. Input lift is the distance that the input arm is getting lifted. So this is you taking your hand and lifting it 4 centimeters. Output lift is negative, if you want to think about it that way, is how much this arm on the other side is moving down, in this case 1 centimeter. Input arm length, now we're talking about arm length, that's lateral lengths, so either 40 or 10. The input one is 40, the output one is 10. So in order to create an equation that makes sense here, let's think about it. We need to do the lift on one side times the length on the other, and vice versa. That's the only way you can get these to work out. And this is the equation that allows you to derive the distal advantage, the opposite of what you would call mechanical advantage, or the reciprocal of it. So in this case, we could say the input arm length is 40, times the output lift, 1, which gives you 40 on this side, is equal to output arm length, so that would be this, 10, times input lift, 4. Well, 10 times 4, that's 40, and this is 40, so this equation works. So this is the only way that the equation works, and as a result of that, you can think about, well, this stuff down here. If I'm closer to the fulcrum than the object I'm lifting, will it be harder or easier for me to lift it? And will I need more or less distance in order to get the same distance output on the other side? So think about those carefully. And then what is the implication for our catapult as a result? If something there is unclear, please send me an email and I will be delighted to help answer it. Now, the rest of the class period we spent fixing up our checkpoints, if you are still missing those, or playing some nice Pictionary, but with a twist. So if you've never played Pictionary, one person is given an idea, a word of some kind to draw, and everyone else tries to guess what they're drawing. Now, in our case, we're playing with these shapes, and you might have to draw a shape from either the top, the front, the side, or as an isometric drawing. So any of these shapes, for instance, let's say you have to draw 5 top. Well, looking straight from the top, you would look, this would look like a rectangle next to another rectangle. And everyone else would have to guess. If you want to do this yourself or with some friends, the list of custom words is right here. And here's some possible websites you can play on. I know that at least Scribble.io is blocked on MyMCPS, but I'm not sure about these other ones. So you'll have to try it. Okay, that brings us to the end of our class. I hope you guys have fantastic holidays. If something is an issue, please send me an email and we can get it worked out. Have a great rest of your day.